Now it starts to be more technical. I hope you really love technology like me and want to see more code. And one of the last questions for the session is how we are prepared. And that means on technical part, how we packaging software. And that is an important part of my talk, to build packages. And that is what more we story is. Packaging software, deliver it very fast in containers. And that changed the world of IT. That is the truth. Before we don't prepare to build real systems. We build software, not systems. And build software is a very funny thing, but build systems can be very hard. And you must learn to prepare for building real systems. That is also the questions about how we can explain Kubernetes to a Java developer. Java developer like software, but they don't like systems. Systems are hardware, and we must be real prepared. And what is helpful? We need a package manager on your Kubernetes cluster to build a real system. It is originally developed from the DICE company. It's now part of from Microsoft, and it is expanded their project to the Cloud Native Foundation last year. And the second generation is available. And it's a very important part for me. We all like our containers, but containers are not the configuration of the real systems. What we really need is a package manager to describe the real system, the whole system with all the databases, message buses, other services around your software. And that is our build in this project. And it means it package all your Kubernetes manifestos. It is a build around a new name. This package are charts built on top of Kubernetes manifests. And it stores not in an image registry, it stores in museums. And it's the same repository name. And now we start a hub on Helm to get a better usage of existing charts. That you can reuse something. And you need a templating language to make it more configurable for your job. Your database names, your accounting, your configuration of your database. And that means we need some template processings. And it is built for scalability, and it's a real good tool for an SAE or developer. And you can search for the database configurations in this hub, and then you can reuse these pre-building blocks. Kubernetes, we all now we can explain Kubernetes, I hope, after the last talk to everyone. And it is built for scaling containers. It is a very huge, the largest project on the planet is open source. The most contributions goes in this space on the world. It is now 5 years old, and it's original developed by Google, and it's really the amazing project in the cloud native space. And what we see is, what's really technical mean, you have an orchestrator. You have a backplane with some schedulers, controllers, and storage of describe your systems. That is this part of the, what's that? That is this part of the story. You have these backplanes, these master, and then you have a lot of minions, the old name of Kubernetes nodes. Nodes are very boring. I like this topic that my workers are minions, self-organized, yellow, small guys, and do the job. And these minions can schedule your software on a lot of different container runtime engine. It can schedule it in normal Docker engines, containerd, but also can schedule your workload directly in virtual machines. And that means that we have a long living system that have no ending. We can span the software, span new boxes, replacing the software of other boxes. Very easy, and we can describe the whole system with a language. And around is a system of network, storage, machines, load balancers, firewalls around the software system. And the primitives on Kubernetes are spanned around on pods. Pods are a group of containers. Pods means a group of whales, a group of Mobies put in together to one box, to one minion, and say, okay, please minion, do the job for me. And around these systems, we must explain something with storage, with security, thinking about how we can redeploy the software with the next versions, how we can describe quotas, limiters, and around that. But what is the challenge? You see, it is a very rich language of description of a system. And if you move from microservice or serverless architectures, your application now have a lot of components, and each component needs their own resources, their own scaling cycle, and it's really, really hard to manage, edit, update all these descriptions in a clear manner, deploy all these configuration on the right places, share and reuse something that you need in other parts of systems, find the right parameters of your software, manage all the releases to roll out your software, define the life cycle, validate the releases after deployment. And that is now you are welcome in the system space, not in the software space. Software is easy, it's an algorithm. But the system must really work. You must communicate with other systems, with humans. And if a human crash, it's die. If a system crash, it's die. But you must restart it, reboot it very fast. And that means you must be prepared. And you must coordinate all these components in the right way. And what we do, we must build components that we can reuse. That's a clever idea that we have in the IT. We must package those things to make it reusable, store it in some repositories that we can easier load it on some boxes, and reuse existing charts, install and uninstall all these things in the different clusters, and have a clear release cycles to all these components, the right order to update something, whatever it is. And that is the rule of Helm, the package manager do. And the concept behind that is a package is a chart of manifest of all these descriptions in Kubernetes, and you can build releases, some versions of that, and can roll forward and roll back these releases on your clusters and play around with that in your development part of the clusters. And don't play around with your production. If you play around with your production, you lose something. Datas, they are dead after that playground. And the other thing is you must coordinate some repositories to store these charts, something you want published in the openness, something you want built by your own team. And you must have a rich templating language to mix these configurations in your Kubernetes manifests and primitives. And how Helm works currently, if you have a client, you can install it on Windows, Linux, macOS, whatever it is. And with this client, you coordinate a service, a tiller service in your cluster, and coordinate the API server in your Kubernetes environment to get your manifest real life. And it's very easy to install. But easy sometimes means you have this, don't trust people that schedule shell script in the wild. That's a very unhappy path of your security. But it's easy, but don't do it on production. The other thing is security. The tiller component is like a root shell in your environment. That component can do everything. It's a boss. And if you coordinate a boss, please trust him. It's easy. And after that, you can download every chart in your clusters, schedule your Tomcat old application, your Postgres, your application, your Redis, very easily from your GitHub repositories directly in your clusters, and span around your release cycle to try out that your release is the right one for your system. That is the Helm flow. So you have some charts in the back, and then easily start these complete systems and place it on a cluster, not on one box, on a cluster. You can place it on a complete cluster with the complete description of the complete system. And the CLI client has a lot of commands. I won't give it a try. To create a new chart repository, install it, resolve all dependencies, search, roll back the releases, delete something, verify it, lint it, and so on. The normal things that we are aware with CLI components. This is a short example. You can create a chart, then delete all the crap that come with the default things, and deploy your configuration map, install it directly in the chart. Before you install it, you can try it out, it's the right one that you really want, and then give it a name, deploy it to your new namespace, and after you checked it, you can delete it. Very easy going. The complexity comes from your software. Software can be really complex, but it's a simple example to do it. But another good point, you can reuse something like your monitoring system. Prometheus and Grafana has pre-built charts, and it's very easy to install it now. It's a feature-rich software, and you can install complete Prometheus with alert managers, metrics from your cluster with a one-liner in a namespace. And then you add a Grafana to it to control these metrics with your dashboards. It's very easy, as before. We see this space to motivate to container. Run a container was very easy, but running on container, start a container process on one box, not on a complete cluster. And now we have, with Helm, we have a CLI client to start a software on a complete cluster, a complex system, a city. You can start a city with all these infrastructure. You can do it with your load balancer, very easy, and have a who am I language to test it, to promote your microservice to the internet. With traffic, you can automatically regenerate Let's Encrypt certificates, and in seconds you have deploy a new site, a new software, a new piece of software on your clusters. And it's repeatable. Every time, every new cluster can do the same. That makes this message very important for us as developer. We all know what a module is and how good a framework is. And now we have this framework from Kubernetes, and now we have a tool to configure this framework, this platform, very easily. In detail, it is a simple directory format. This package format has a manifest with a chart YAML that you can explain something, add a license to that, a README, and then have some subcharts or components that you will reuse, have a requirement file, and some templates to add your Kubernetes manifest to a directory, and then it is finished. And then you have some value files for different environments, and then you can promote it to different environments. It's a very easy packaging format. In detail, you have this chart. You can explain something for your users, a version, add some keywords that you can better find your components on some hubs or museums, add a HTTP link, a source code, and a maintainer that are happy people to solve the bugs. And then you have these values file to add some clever parameters and can reuse these parameters in a variation from the original developers. Add some requirements that my piece of software must have a Postgres database and a Redis store in the back. And I can have those conditions that in different systems I have these Postgres. If Postgres enabled, then I also enable the Redis. And if Postgres don't enable, I don't start my Redis. That's easy. But the templating language, I don't like that. It is including the Go templating language. And it's not so readable, I think. It's a mess at the moment, but the community detects these strange things, and in the next generation of Helm, the Lua scripts come on board, that we have a scripting language, it's complete programming language, and then I hope these dialects can be more readable. That's a problem currently. But what you can do with these helper functions to building some blocks that you have in different manifestos and have some macros that you can reuse in different manifests to place it around. And then you have the normal things, some flow control things that you have in everything else. You have some switches, then you can variate those documents very easily if you have some data on it, to have values directly dependent, and have an if statement if something add these mark true, and if not, you have don't these parameters that you can variate some data in your deployments. Flow control with this, and you can add some data from files. You can iterate about some lists that you've before defined to add something in your things, and have variables to add something. Normal things has nested templates that you can place macros on different places in different documents, and that makes the life a little bit complex. Now we need software developers to understand that description of our systems. But it's a normal way that we software developers thinking and placing something in text files. Now it's not XML, it's just YAML, but it's not better. You can add some tricks, some functionalities that you don't have. It's like you need an pull secret for your images of your private registry. I hope you have one. And then you must build an YAML document and can add some pipe functions, go with a function-based language, and then you must encode it, and but it makes it not readable. That's on the end. Find something in other templates is a good point to looking inside these topics to learn from other guys how you can handle some complexities in your dialect. And on the end, one of the biggest problems in the space of Kubernetes that I detect is the world is stateless, and that means you have no dependencies between all these parts. But that's not really true in your systems. You must coordinate which parts of your system come on board, and that needs dependencies. And that means if you change your password, then your pods must be redeployed to accept these configurations change. And that means in the Helm packaging world to coordinate dependencies. And one of these parts is, here you see I can add an annotation in these deployment descriptor, and every time an annotation is changed, then it means all pods are redeployed. And that's great, but you must do it by your hand. You must coordinate your dependencies by your, or you call recreate all pods in your complete system, but that means something goes offline. If you don't, means it don't work, come on the booth and test the hybrid cluster that we have set it up with some deployment strategies of Kubernetes, and sometimes it is not so working that you expected. I'm very true about that. Please try it out to upgrade something. Something means whatever it is, but something breaks every time if you do it, a change. Old operators here know the sentence, don't change a running system. Yeah. If you change a system, then you are in trouble. Do it oftenly and frequently, you are more in trouble. What you can do to coordinate something around your system, sometimes you must have a pre-installed procedure or a pre-delete something to clean up something, and you can add some annotations to some Kubernetes resources that only starts on this life cycle that you can have before your real system are installed. You can have some pods to start to do whatever it is. Whatever it is means some of you use relational databases. Who has used a relational database in production? Yeah. What use the others? No SQL databases? Okay, you're also in trouble. But sometimes you need pre-install a schema, prepare some data for your systems, and that means these pre-install hooks for the lifecycle of your manifest to do something before your real software is started, or do something before you can do an upgrade. If you upgrade your database, it is a clever decision to make before an update, a backup. Not an update, a backup. Before you make an update, please make a backup if you don't trust your systems. And if you're a software developer, you change something, but you don't need what the real effect is on your developer phase. And it's clever to make an backup before you make an update. What it means in technical detail? It means you can load your charge, and before something happens on your real systems, the pre-install hooks are sorted, and then it is started. And before they don't terminate it, you don't load your start. If you terminate it, you load your start, and then install all these pre-installed hooks and wait that they come back, and then the release is finished. And then you can access the code in your client that your installation is completed. Sometimes it is very hard to test those systems. You have a lot of variation in these systems. Now you have packaging systems to generate more variations. Now we have 500 or more charts in the world. And every day a change comes on these stable charts. And if you check it out, the newest one, it breaks. And what it means, it is untested completely. In every training that we have these problems. We make a tryout, and it happens as before. Not. It crashes sometimes. The word is changed too fast for the examples that we can set up. And I looked in this space and see, okay, in this space are all cowboys. They want, try out, give their best, and let the sun shining. But they don't respect the functionalities as before. The Helm charting has a very easy going for that. After your system is set up, you can start some Kubernetes pods in your systems to test your system. And here's the easy declaration for that. You need these annotation, and then you start a container inside your Kubernetes cluster to test something. Here it is a very easy checking of support availability, but you can also add more space. And if you search for that, you can look in server spec. Server spec is a Ruby framework to test infrastructure and add those components inside those parts. Then you can test your setup of your systems and it's really functional or not. But what I also found is we generate a lot of texts in these Helm packaging. The complete description of Kubernetes is text files, and it's YAML files. And YAML files means you can check it very easily. And I find these unit tests plugin for a while, and it have a behavior-driven dialect, and it means you can include different variation of your values, and then check that the resulting text files is the same as before. And that's a good thing if you don't like these Go templating languages, but please add some unit test in your space that you can check that the resulting files have no variation with your change as before. That is a good one for infrastructure testing. And if you look on all these existing charts in the museum, it's sometimes very hard to find the right one for you in the right version. And they have a very quick change policies in most of these charts that currently available. And the number is really, really growing very, very fast. At the start of last year, we have 20. At the end of the years, we have nearly 300. And I see that is only in the official stable chart museum. That's not worldwide. Worldwide, I see 10,000 of charts. And that makes your life not easier. You must choose twice and very clever. And if your system is running, don't follow the change path too fast. Yeah. What you see at the end is the normal service architecture that Kubernetes offers for us. And that means you wrote your software as a container, split around containers, and then you must describe the complete system with 20 documents. And what that means is you need a lot of help. And that is what Helm offered to you to make it easier for you that you only change your container image, and then you have all these other documents really set up for your complete team. If you have to build a serverless or microservice framework, then have a clever chart for everything and have spent a little bit time to the complete Kubernetes space and make a clever setup that works for all your microservices in some variations. Don't let every developer hack around your Kubernetes documents. That is not the best way that you can do. We prepare on the booth a voting example, a very prominent container examples, and split it around in some microservices. And you want to review that, please come to the booth, and then we can talk about this example and how we can do that. And work hard, dream big is one of the lessons that we learned in the last 3 months to set up these examples for Kubernetes. It is so hard to make it right. And it needs a lot of discussions to do that right, and it's a very, very, very simple problem. The problem is have a voting for something that you can vote for. Here as example, Kubernetes, Swarm, Nomad, and Mesosphere, and you see 100% of the voters love Kubernetes. Yeah. Who is try out another thing? Here in the room, who use Kubernetes? And the others? Okay, talk with that. Enough people in the room to motivate the 100% vote. But it's a very simple one, but in a microservice space, it means you have one service for the vote and another service for the result, and in the middle another service to coordinate some voting to transfer to results. And in the back, you have a Postgres database, a Redis cache, and it grows. And what we see is Kubernetes is stacking. At the normal ways, you have your Kubernetes setups, and a lot of people tell you that it's complicated, but it is only the first day. The second day is to set up the complete infrastructure, monitoring, load balancing, databases, find a clever description for your services, and that is not the happy path on your life. Thinking about security, don't have these tiller, these super admin to your clusters. Please add smaller tillers for every namespace one. That is what these diagram shows. And you see an explosion of documents to describe the security in mind thing. And the lessons that we learned is we use this immutable deployment pattern, replace everything. Only system pods needs access to the API server. We learned add security at the first time, not do it in the end of your project. Limit your network access, have multiple tillers to set up your trusted zones for different teams. Have a CVA checker that not everything comes to your clusters. Add more knowledge about systems to your team. That's a very clever one. And share this knowledge on conferences. And thinking about chaos engineering, let it crash. Not in the happy path, all working. I have nice setups, the systems, but I don't have reboot all machines. That can be a problem. And automate whatever you can. And then you have a blueprint. What we are thinking on the B42 is that it needs currently more to rethink your IT. It is only not the technical part, it's also an architectural part, an organizational part, and you need a lot of training on all these technologies. I have talked now 30 minutes about a lot of technologies, but use that very clever needs training on the job. Do it again and again and again. Don't say, okay, here I have copy-paste this example from the internet and it works. That is not enough. And have a blueprint and discuss it with your organization architect, that you have a real good system and your knowledge. And the best thing what you can do is stay hungry and stay foolish. And we're all hungry now, I hope. The best thing on Helm is you can play around with technology. With all these other technologies like GitLab or Vault or service meshes or Knative on a very easy way. And that is the offering that Helm does. Before we have these container, one legal part, and now we have a description in Kubernetes environment for complete systems, and now we can make experience in these real systems, and that is a pleasure for me. And now I hope you have a lot of questions.
I will work.
Thanks a lot. About the database handling, I was really wondering why you put that into a pre-deployment hook, especially in the context of having a shared database that is shared between the currently running version and the next version. So why not put it into an init container, for example, so that, let's say, the first pod to get the new version will then do the upgrade. In any case, all the others have to handle that and be happy with a newer version schema. What's the benefit of doing that in the pre-commit hooks and the pre-install hooks? The other question I had is, what about canary deployments? Can Helm already actually manage a canary deployment end-to-end, including some feedback cycle through some monitoring system and rolling back to the previous version if the canary deployment doesn't work out? Or is it still something that users have to do manual on the command line and watch their deployments, which is so old-fashioned?
Okay, the first question was why I was thinking about these pre-hooks. It is the init containers is if you have start multiple pods in parallel, then all your init containers do the same job. And if you place your init procedure in a separate pod, then it is works one time, not a whole story. Every time you restart a pod, you don't need this init container, but you can add a check that another container has makes the migration. That also works for me. It's the same story. Now, the second part is have Helm everything about canary deployment. No, it's a package manager and deploy your software. If you have a description in your Kubernetes primitives, then it can do the jobs, and it's very helpful to have a service mesh in this situation to have real canary deployments to coordinate. It is a coordination between your documents and proxies. It's not coordinate to bring all your software on top. What Helm do is a bigger rollback your complete deployment to another stage as before, and it can be very problematic to do it in this way. That's true.
Hi. Thanks for the talk. I'm here.
Ah,
yes.
Sorry. I see the other question.
Sorry. Yeah, thank you. Right now we are using Helm for templating only. And I couldn't convince myself why I should use Helm as a deployment or package manager. Because like, what is it one thing you can say that Helm gives me other than whatever I can do with kubectl apply and status rollout?
It is a little bit coordinate ordering. kubectl don't order your documents, and the tiller have an order that your namespaces create first before your deployment, and before your deployment you have some security documents inside, and after your deployment you deploy the ingress documents. That's more an ordering that you add that, and it saves the state of your system in the API server, and then you can roll forward and back.
Okay, state is actually a good part of it.
Yes.
But then is it like, do you have different charts for the order you mentioned?
Yes.
Because then don't I already run the Helm with the chart order, or can I actually run the Helm that can take a couple of charts and can order them?
Yeah,
because
they have a couple of charts, and then make a ordering for every chart component, or have an ordering for the sub charts and so on,
okay.
not for all documents.
Okay.
And that is a good ordering to have a clearer setup. It's more built for developer if you change a lot, and not so helpful for production. But on the developer phase, you need more deployments and change and experiments on your local development environment. It's handy for that phase of the project. And I think it's a very important part in my life to change, to describe the complete system with Helm, and have another colleague and make it sure that you can release the same stage that I have on my box.
Yeah, super. Thank
That's
you.
helpful.
Thank you.
Hey, Peter. So in the CNCF end user supporter group, which contains a lot of companies like being far or not so far in the cloud native journey, actually nobody in our calls actually uses Helm with a server side tiller. So just as she mentioned earlier, just maybe as a templating engine, but nothing more. So actually, how does this fit with kind of the nice things out there, everybody jumping on Helm, but the real companies actually being like advanced in developer journey, actually not really using Helm to how you described it here. And my second question, which my web search didn't answer right now, is kind of what is the Helm 3? When is it coming without tiller?
The first thing is why we choose Helm is that is a very prominent template generator currently that have a lot of components that people can reuse, and you can train people for this area that we choose in trainings, why we invest time in Helm. But it exists a lot of other components, Customize or JSONnet, CASONet, to have clever algorithm for templating all these stuffs, and we won't see in this year which of these solutions are offers its space. But all other solutions don't share their components so prominent in the net like the Helm community. If you're really interested to see our existing configuration of a lot of systems, then you invest your time in Helm, and after you invest your time, choose the best algorithm for your templating, and I think CASONet is a very clever one, and we won't see. And the other sub-question was how fast the tiller-less Helm 3 comes on board. I don't know. I don't know. I hope this year, but I also last year the same, and I hope now the developer stream is invest more time to get it finished. I hope in the summer or so. I hope that they can do. But the tiller part is a very strange thing in this Helm thing. It's a security nightmare, I think. Yeah.
Yeah. So next question, the last one, before we want to gather for the photo. So. Not true. Yeah. Shalom.
You don't expect me to run out of questions. Are there any alternatives to Helm that you would like us to consider that maybe are rising stars, even if they don't yet share millions of charts?
I think I've tried out CASONet. It's a JSON-based thing with overload or something. That seems a good alternative to have templating on this Kubernetes space. But sometimes I think if you describe a whole system with a packaging system, you end in a monolithic pattern. And I don't like that. I like a system that is described by pipelines with the smaller parts of the systems, and that easier I can try out to change these smaller parts. Don't describe the complete world that I'm living in. I think that is the better decision. I see these are anti-pattern, I think, in the configuration space before in Puppet, in Chef, in Ansible, and so that you describe your complete landscape of your complete system in one configuration management systems, and that is the dangerous side of configuration management. Invest your time, please, in a solution to have a lot of smaller parts and have a clever built by your own algorithm to change that in the right order, in the right value maker stream. That is the thing. Don't invest so many time in get it bigger and bigger and bigger.
Yeah, I want only to make a little extension to that. There's currently in Kubernetes 1.14, Customize will be also implemented in kubectl. So you can directly use Customize with kubectl out of the box. Google patched it in December during the holidays. So that can you also use. Customize will be, I think, will be the next templating standard from Kubernetes out of the box. But it has a little bit different approaches to the Helm. And it's like Peter said, that you should choose your, it's like the same with which programming language should I use. Use the language that solves your problem in your way that you can handle it. Yeah.
But the biggest thing in this packaging space is you must invest your time to learn how real systems are make you configurable. And currently, for me, it is Helm. You can see a lot of charts to invest your times to learn how Postgres or Prometheus is set up right. That is a good part of the story.
Yeah, I'd like to add that if you're interested in some other ways to install stuff, you can come tomorrow to my talk, which is about operators. And actually, operators is similar to Helm, except that it's probably better. I'm not sure. I hope I can
We will
convince
see
you
this.
tomorrow. So if you like, you can come. Okay.
Nice pitch. We will see tomorrow.
You won't see, you know.
I'm very excited to it, looking forward to it. But now what we do is we gather us outside out of the building for a group photo, and then we're going to lunch. The lunch will be also on the floor. So
Many thanks for coming.
many thanks. And